Good morning, everybody. It's really great to see your interest and have you join and dial in. Welcome to this episode of the Battery Pass webinar series. This time today on the battery carbon footprint, specifically on the requirements that the EU battery regulation, which has just passed yesterday and is finally gone through a big milestone that we've all been waiting for a long time. What the battery regulation will set out, and specifically, of course, what the battery passport requirements will be in that regard. I'm Tim Anfale, Director at Systemic for Automotive and Batteries, founder of the Battery Pass Consortium, and I'm going to lead you through the setup and the agenda a little bit before I hand over to our experts that will actually run the webinar. If you could go on, Achim, yeah, you're obviously at the right time here today. This is the last of our webinars, of 5 webinars that we are conducting to shed a little bit more light onto our content guidance that the Battery Pass group published in April, the first comprehensive guidance that has been developed for the battery passport as per the EU regulation, and today, of course, on battery carbon footprint. Previous ones had covered circularity, supply chain due diligence, performance, and of course the overall project and concept of the battery passport. So moving on, who do we have? Myself, of course, and we have the content experts, Anna and Achim from Systemic, that led our analysis and crafting of this chapter of the battery content guidance that will lead you through what the content of the guidance is and give a deep dive on end-of-life allocation rules, which is a pivotal element to the whole thing and still a work in progress in the overall methodological landscape. So quite a cutting-edge topic today. And then we have our industry experts from the group. We have Dr. Bodo Müller from BASF, Sustainability Manager for Battery Minerals and Precious Metals, so quite a veteran in the field, as well as Ketan Vaidya, Life Cycle Assessment Analyst at Northvolt, and they're responsible for a lot of the great work that our colleagues in the North are doing. These will then join a moderated expert discussion for the second part of the session. And here we see the agenda. So after my little intro about the framing, we're going to dive into the core content on the footprint requirements that the EU sets out generally, and the calculation approach as well, and then with the deep dive from end of life and recycling life stage, followed by the moderated expert discussion, and then 25 minutes on a Q&A. So please, if you have questions, comments, annotations at any time, please use the Q&A function and feed in your questions, and we'll raise them and discuss them later on. Couple of ground rules, quite importantly, so the meeting is being recorded, so if you join and stay in, you consent with that. All participants' videos are disabled, so save the bandwidth here for all of us, and you're also muted to guarantee good audio quality. So please do use the Q&A function, and during the Q&A, if you called out, raise your hand so we can call you out and could bring you into the panel for the discussion. Important note, this is pre-competitive, so please do not share any business-specific information, of course. Moving on, if you could click forward, Achim. Beautiful. So we have 3 questions to you that we would like to raise. And so we're going to start a little survey in a second. Very quickly, we'd like to know, first, which type of organization are you working for? Then second, how familiar are you already with the requirements of the battery passport? And third, did you already read our content guidance? So please respond, and we'll have a look who is with us today. We're going to give you a few seconds. Right, so thank you for putting in your responses. Let's have a look if we're already concluding and can show the results. Always quite interesting who's actually joining which session. Actually quite differing between the different topics, sometimes with a strong industry emphasis and sometimes more equally distributed. Beautiful. Right, so in terms of the spread, I think we have around half of you from industry, 20% from research academia, and about 15 from consulting, and the rest spread out. So that's a nice distribution. Excellent, and you already bring some of the knowledge on the requirements, which is great. But of course, there's a lot to digest. So I hope that with our webinar today, we can shed a little bit more light on it and add your knowledge. And great that at least a good third of you have already read through our content guidance. Thank you very much for bearing with us. It's a big document. Alrighty, moving on. Thank you very much. Just a very brief introduction of the battery passport. So what are we actually talking about if we talk the battery pass? So we're a consortium of 11 partners, originally started by Systemic, who's in lead, building from the Circular Economy Initiative Germany, in which we identified basically the battery passport as a key enabler for a circular and sustainable battery economy. This project is co-funded by the German Ministry for Economic Affairs and Climate Action quite generously as a strategic project in their batteries program. And we aim basically to support by providing content and technical guidance for industry and also comments for the regulator to advance the implementation of the EU battery passport, seeing that this is a very complex undertaking, and it is very, very important that a lot of the maybe ambiguities that still exist are clarified as fast and much as possible. We're also developing a technical demonstrator, how this could actually work in practice, and are currently developing a value assessment. So what could this actually mean in practice for the businesses, for the environment, for social aspects? And we've been going for 1 year since last year, April, and we have another 2 to go. So end of this year, actually, we're going to bring out the second major milestone, the technical guidance. Moving on. So what is our focus? We look at the regulatory compliance. So really looking into the EU battery regulation and what does it mean to become compliant, so that actually the core of what battery passports will be, which will fundamentally be defined by the EU regulation, which of course sets a mandatory battery passport, can be abided by. So we do interpret the regulatory text and we look into cross-referencing with other regulations and provide interpretations as well as suggestions where there's ambiguity, that is in line with the aims of the regulation. So the scope really is on the EU and EU regulation. Of course, we recognize other aspects such as US regulations, Chinese, or also multi-stakeholder activities like Catena-X or the Global Battery Alliance. Moving on. Yeah, so the content that we talk about today, you can download it here if you whip out your phone, is coming from our analysis we did in our content guidance. As I said, we launched in April at the Hannover Messe. We were launched by State Secretary Michael Kellner from the ministry. And this includes both a comprehensive report and an executive summary for those of you that don't have the time for a 250-page detailed tome, as well as a data attribute long list where we accumulated and looked at the detailed data that will actually have to be reported and or made available via the battery passport. Moving on, we basically have this as the scope of what a battery passport according to the EU regulation is. We clustered this in 7 categories on fundamental basic information, labels and certification, supply chain due diligence info, circularity relevant information, materials and composition information, performance and durability, and lastly, but very much not least, carbon footprint information. And this is, of course, the topic of today, diving into that in our expert presentation in a second. All right, and with that, we move on. And I hand over to you, Achim. Take us away for the actual content of the webinar.
Thank you very much, Tilman. Thank you very much for the introduction, and I am very happy to welcome you to the content part of the carbon footprint webinar today. My name is Achim and I led the Battery Pass Carbon Footprint workstream. So therefore, it's my pleasure to walk you through some of the main topics concerning the carbon footprint requirements as per the battery regulation. So the calculation of a product carbon footprint is very complex, and we could spend hours discussing the details, but what we will focus on today will be the general requirements and calculation approach, as well as a quick glance on the end-of-life and recycling life cycle stage. The overall framework is, of course, the battery passport, but we will later see that the carbon footprint requirements are kind of detached from the battery passport, even though the data and metrics will have to be reported via the battery passport. So starting with the general scope and background. The battery regulation mandates 3 carbon footprint instruments that are implemented consecutively. The carbon footprint declaration, whereby the carbon footprint for each battery model placed on the market needs to be declared in the market conformity assessment. The carbon footprint performance classes, which mean that based on the carbon footprint declarations, a certain performance class distribution will be established, which indicates then a low to high embedded emission of the batteries. Thirdly, the carbon footprint maximum threshold will be implemented as a last instrument and sets a carbon footprint value above which no battery may be placed on the market. As you can see from the timeline on the lower part of the slide, the implementation of the instruments and per battery application is consecutive. So for example, for electric vehicle batteries, the carbon footprint declaration is expected to be required from February 2025 onwards. For industrial batteries above 2 kWh, except those with exclusively external storage from February 2026, and for those with exclusively external storage from August 2030. For light means of transport batteries, the carbon footprint must be declared from August 2028 onwards. Roughly 1.5 years after the carbon footprint declaration is implemented, the carbon footprint performance classes will be applicable. And again, 1.5 years later, the maximum threshold will be implemented. This is, of course, also consecutive as per the battery applications. Please note there that the implementation date depends on the entry into force date of the battery regulation. And as Tillman has said, yesterday, the Council formally adopted the battery regulation. So now it is just a matter of finalizing the publication in the official journal, which we expect to take place in August. However, there might be, of course, always postponements, so to say, such that the implementation dates might vary from this chart. Note also that the carbon footprint of electric vehicle and industrial batteries needs to be declared even before the battery passport is implemented, as I've said before. But once the battery passport is required for all batteries in scope, several data attributes need to be publicly available from there, which you can see on the left. So the carbon footprint declared, the share of the carbon footprint per life cycle stage, a web link to the carbon footprint study, which has to be filed as a technical documentation in the market conformity assessment, as well as information about manufacturer, place of manufacturing, and the battery model, and the performance class once it's implemented. For those battery applications where the carbon footprint requirements kick in later, the battery passport does not need to hold this in yet. But once it is implemented within in the framework of the battery regulation, as per the Article 7 and Annex 2, then the battery passport also needs to report the carbon footprint data for these applications, which are rather implemented after 2027. So if we move on, how is the carbon footprint actually calculated? As I said, this is very complex and it requires a lot of guidance. And the European Union's Joint Research Center has recently published a rule book for calculating the carbon footprint for electric vehicle batteries, which will be the basis for the delegated act, which has been kicked off last week. So basically for each battery application and for each instrument, there will be a delegated act, which is basically a secondary legislation, which specifies the requirements per law. And these methodologies per law are then applicable in the European Union for the carbon footprint declaration, for the performance classes, and for the maximum threshold. So for each application instrument, there is also a timeline which is taking place before the respective instruments are implemented. And as I said last week, the carbon footprint methodological delegated act for electric vehicles has been kicked off based on the Joint Research Center's rules for electric vehicle batteries. So this will certainly set the stage for other applications such as industrial batteries, but also for light means of transport batteries. If we move on now, what does the JRC document say actually? It says a lot. It is very complex, as I said, but the most important topics are the way the functional unit is specified, the way electricity is modeled, the way the end-of-life allocation is done, and the way the system boundaries are specified, including the data requirements. And this is what we want to discuss today, the system boundaries as per the JRC document, as well as the end-of-life allocation topic, because we at Battery Pass dealt with the end-of-life allocation in great detail over the past year. So the system boundary defines which life cycle stage and product components need to be taken into consideration for calculating the battery carbon footprint. The JRC defines the system boundary as the battery, so the entire battery pack containing passive components such as the battery management system and cooling system. The life cycle stages, in contrast, are raw material production and pre-processing, so the way materials are dug out of the ground, if it's primary material, and then processed to precursors. Then the product manufacturing itself, the distribution, and end-of-life and recycling life cycle stage need to be considered. This effectively means that the use phase is excluded. And as you can see in the red box in the middle, the manufacturing life cycle stage starts with cathode and anode active material production and continues to cell production, module, and pack assembly. And this is very important, this red circle, because for this life cycle stage, company-specific, or also called primary data, are mandated. Primary data are directly measured or collected from one or multiple facilities which are representative for the activities of a company. So to calculate the carbon footprint, so-called company-specific activity data and elementary flows must be collected and multiplied with emissions factors. This is obviously very technical terminology, but activity data are, for example, the amount of materials consumed in the process, and elementary flows are the type of materials consumed in the process. So for example, the type of electricity or the type of energy, so to say, and the amount of energy per type, so electricity. The emissions factors within this red circle may be also secondary data. So you need to collect primary activity data, but you may use secondary emissions factors from environmental footprint compliant databases. Secondary data mean any data set that is not company specific. So for example, from a database. And then this will mostly be regional average data compiled by the European Commission and provided on a node, which they call node, on the EF compliant dataset landing page. So coming back again, this means that in the manufacturing life cycle stage, battery producers placing batteries on the market need to collect company-specific activity data for the processes along this step from cathode active material production to battery pack assembly and multiply them with according emissions factors. Again, one example, maybe activity data are the amount of energy and auxiliary materials used in each of the respective production steps. And emissions factors are then used to be in compliance with the JRC rules. So for example, electricity modeling, there are specific requirements, or EF compliant data sets for material consumed. So for example, the carbon intensity of sodium sulfate or chemicals used in the process. For all other life cycle stages, secondary data for the entire process may be used, which means, for instance, average data of nickel sulfate production from one specific region if we look at the raw material acquisition and pre-processing stage. Nevertheless, the Battery Pass Consortium recommends calculating primary data-based carbon footprints along the entire supply chain based on the Global Battery Alliance's Greenhouse Gas Rulebook, because this provides detailed guidance on collecting primary activity data along the entire supply chain, along each processing step that are typically implemented in industry, which makes us able to move towards an end-to-end company-specific carbon footprint accounting. It is based on existing standards for product carbon footprinting, and with some exceptions, which are now being discussed in the Global Battery Alliance public consultation, it is also in alignment with the product environmental footprint methodology rules. So the GBA has published the version 1.5 by now, and it is in public consultation if you wish to comment on anything that is in there. And the importance here is really this focus on primary data, because we believe that only with primary data, operational optimization of the carbon footprint along the value chain may be enabled, because secondary data would resort to actually using default values and averages from databases. And at Battery Pass, we complemented the GBA GHG rulebook for the life cycle stages distribution and end of life and recycling. And we provide detailed guidance on how to collect and aggregate carbon emission data along these life cycle stages. The GBA's version 1.5, which I said is in public consultation, incorporated the Battery Pass rule and it now provides a cradle-to-grave rulebook for primary database accounting end-to-end. Because we dealt in very great detail with the end-of-life allocation, we at the Battery Pass decided to also focus a bit on the end-of-life life cycle stage today, because this is an essential topic and the choice of the method has strong implications on the overall footprint. We analyzed internationally existing standards such as the ISO and the GHG protocol, and there two main approaches apply. The first one is the cutoff approach. The second one is the substitution approach. The cutoff approach effectively allocates recycling emissions only via the recycled content. So therefore, there is no end-of-life recycling emissions, but only disposal emissions of the unrecyclable fraction. This effectively means that the treatment emissions from recycling of a battery come from a previous life cycle. And these are taken into account while the recycling of the battery, for which the carbon footprint is actually calculated, is accounted in the next system boundary. So now we are reaching circular methodologies here in terms of where we do account for the benefits of circular actions in the respective system boundaries. And to sum up, only burdens associated with the recycled content are taken into consideration, which means that there is an indirect incentive to actually use recycled content to optimize the carbon footprint of the battery. The substitution approach, in contrast, allocates the end of life to the battery for which the carbon footprint is calculated and assigns end of life carbon credits. This carbon credit is given as it is assumed that the recovered material substitutes primary material. Thus, the emissions from the end-of-life recycling are subtracted by the emissions from primary material assumed to be substituted in the next life cycle. To avoid double counting between life cycles, no recycled content emissions may be accounted for. Therefore, only production emissions are to be accounted for as if they were all primary materials. And this would, in theory, incentivize the use of recyclable materials, because the more recyclable materials are, the higher the end-of-life credits. But there is a third option, which has been developed to balance between the use of recycled content and the supply of secondary materials. And it has been developed in the context of the European Union's product environmental footprint methodology, which is to be applied as per the battery regulation. The circular footprint formula is therefore expected to be mandatorily applied for the carbon footprint declaration when placing a battery on the market. At least it is proposed by the JRC as the basis for the delegated act, which specifies the footprint methodology per law, which was recently kicked off. So we, depending on the outcome of the discussions in the delegated act, it is to be expected that some form of the CFF is applied if there is no backfiring in terms of political decisions. It is fairly complex, but in essence, it balances the burdens associated with the recycled content and the credit given for recovered materials at end of life via an allocation factor A. And this is set to a specific value that weighs more strongly either the recycled content or the recovery at end of life, depending on the market situation of the respective material. So if the A factor, for example, is set to 1, this would model the cutoff approach. If it is set to 0, it would model the substitution approach. However, currently it is specified for metals, for example, at 0.2, which approximate the substitution approach and therefore yields high end-of-life credits. So the formula is very complex, but in essence, on the left, you have primary material input. This part is secondary material input, so the way recycled content emissions are calculated. Then we go on to secondary material output, where the end-of-life credits are calculated by subtracting from the recycling emissions some emissions from primary material assumed to be substituted. And then the formula goes on to calculate energy recovery emissions and as well as disposal, which is basically incineration or landfilling. We could spend hours discussing actually each of these parameters, but important to understand is this. The circular footprint formula has to be applied for each material contained in the battery. And in the battery regulation, it has to be calculated when placing a battery on the market for the mandatory carbon footprint declaration. Therefore, primary data may be used for primary materials and recycled content, so the left-hand side of the formula. For the end-of-life part of the formula, it relies on assumptions on the end of life of the battery, which takes place 10 to 15 years and on average after the placement on the market. And as there are many factors influencing where the battery actually ends up, the end of life credits are difficult to verify when placing the battery on the market. And therefore, mostly default values and recycling scenarios will be used to calculate these emissions. So let's have a look what this actually means in terms of numbers and implications. We modeled the effect of the three approaches on the cathode materials using the 2018 PEF-CR inventory. The results are displayed in carbon emissions per cathode materials contained in 1 kilogram of battery materials. We used the EU minimum recycled content targets for modeling the recycled content burdens. For the material recovery, we used the efficiencies provided by the PEF-CR inventory, and for the circular footprint formula, we used default values as provided by the PEF methodology. In very brevity, this model shows that actually the cutoff approach yields the most conservative estimate, focusing on emissions as they have occurred until placement on the market, which is highlighted by the green circle, which basically says that primary, so company-specific data are available until the point of placement on the market. As the recycled content share in cathode materials is currently low, the impact of recycled content emissions on reducing the primary footprint is also rather low. Compared to if only primary material emissions would have been used, the footprint is reduced by 7%. So if you compare the 3.43 to the 3.7. The substitution, in contrast, yields the lowest overall carbon footprint and effectively reduces the impact of the cathode materials by 42% through the end-of-life credits. This is due to the high end-of-life recovery rates for the main metals contained in the cathode. And the third formula, the circular footprint formula, actually balances both approaches and yields results that are in between the cutoff and the substitution approach. And due to the specification of the A factor, it still reduces the material-specific carbon footprint by 34%. So the implications on the battery carbon footprint may be substantial depending on the material composition. Here we only modeled the raw material and acquisition lifecycle stage, but if we triangulate this based on the PEF-CR inventory results, this might lead to a 6 to 8% reduction of the entire battery footprint due to end-of-life credits in the substitution approach or the circular footprint formula. And why is this relevant? Because the situation is now that leading carbon accounting initiatives rather support the cutoff approach. And this is particularly true where carbon accounting systems are developed to collect and aggregate primary, so company-specific data along the value chains. And also our battery path analyses have shown that the cutoff approach is the most transparent approach, given that static carbon footprints are used for the EU battery regulation declaration. And this is why in our battery path rules for the end of life and recycling, we have provided a primary database accounting methodology under the cutoff approach, which nevertheless could be translated into the circular footprint formula requirements as per the PEF methodology and the battery regulation in case it is implemented in the delegated act. So ultimately, the carbon footprints need to be comparable, and given global supply chains, the application of particular methodologies lead to different results. It will be very interesting how global initiatives will deal with this European Union requirements. And I think there's no better point to actually jump to the expert panel now. And this is why I want to introduce to you two experts in the field of batteries and carbon footprint accounting, with whom we both had the pleasure to work in the battery path and in the context of EU standards. So the first colleague is Bodo Müller. He has been already introduced by Tillmann, but he's the sustainability manager in the battery minerals and precious metals department at BASF. And BASF has recently opened their cathode active material and battery recycling plant in Schwarzheide, Germany. The second expert is Ketan Vaidya. He is a life cycle assessment analyst at Northvolt, and Northvolt is one of the leading battery producers in Europe with the aim to provide low carbon and green battery cells and packs. The panel will be moderated by my colleague Anna Braunfels. So Anna. the stage is yours.
Thank you so much, Achim, for giving us this overview on the content already, and welcome to the moderated panel discussion. And thanks also from my side already to Ketan and Bodo for joining us and providing their expertise. I want to start with a pretty basic question to you, Ketan. So how do you collect data and calculate actually carbon footprint as a battery manufacturer?
Mm-hmm. Yeah, thanks, Anna. I think we should start really at the fundamentals, and it is fairly straightforward. If I'm to say that, Achim explained it in a very many details, but essentially it was referring. Now I'm referring to slide 16, but it is amount of materials or resources that you consume to make a product multiplied by emission factors associated with those resources. So first term, what I said was the data around consumption. And then that can come from your bill of material, your bill of process in terms of what are the different chemicals that are being used along the production process of a battery, main electrode, main cell assembly, and so on and so forth. Then we talk about energy and all the inputs that go into the production of the process. So how this happens is now the GRC report also elaborates and clarifies what are the requirements and how this data should be collected, and that refers to ISO standard, I believe, and this can happen with the help of digitalization and having data collection across the production processes. So this refers a lot to the primary data, and then we come to the emission factors or the impact, whatever we are multiplying it with. This is either coming from a secondary database or coming from primary data specific to the production of each and every material. And then that is defined, I believe, in section 6.1, where there are 3 different ways to do this. One is how, so now we are talking about how specifically a company-specific data can be shared with your downstream stakeholders. And that can be done either by a verified by a study, or by sharing activity data, or by sharing this data to a third-party company who then does the analysis and shares the final results. So it's two parts. One is how much do we consume to make a product, and what it means that that consumption specific to the materials, how they are made, and so on.
Thank you so much. So I think this is already really helpful to understand from a practical point of view what we're talking about with the calculation methodology. So thank you for that insightful answer. So now I would like to ask Bodo, do you think that the regulatory requirements are feasible to implement? Or in other words, what are practical challenges that you, BASF, as a cathode active material producer and prospectively also recycler, are facing when implementing the carbon footprint requirements?
Yeah, thanks, Anna, for the question, and hello to all participants. Yeah, I would say I'm optimistic that, so regarding to your first question, that the regulatory requirements can be fulfilled by the battery value chain. But of course, looking at the practical things, a lot of things still needs to happen. For example, IT tools needs to be developed that can treat confidential data exchange. And these IT tools also need to make secure that not someone downstream can see the whole value chain, right? So that because that is also confidential information, and data exchange should be from a supplier to customer, but not to the customer of the customer. So the customer should just use the data to further calculate the PCF. And that is basically one of the main challenges that I currently see, how to secure that, and that also not one company has access to all the confidential data. So also the data storage, where should that happen, and how do you guarantee that not some data could be leaked, because it's all sensitive and confidential information. Also, these IT tools would be relevant for documentation of, for example, recycled content and origin of materials, because this kind of information is, of course, very important to calculate the PCF. looking especially on recycling, and if you have the ambition to fulfill the voluntary part of batteries regulation that deals down with the primary data collection from recycling, there you also need to see there are some challenges, as a lot of very small or rather small companies are dealing with that. Yeah, so just think of the scrap yards, black mass producers, batteries dismantlers. Also logistics needs to be in there. So it's of course a lot of big companies drive the electromobility, but the smaller companies, they would need to deliver data, and they are also of course not yet aware of it. And it's also yeah, so they need also to learn what's being required. Furthermore, in recycling, you see a very dynamic industry. So that means technologies develop very fast. A lot of things are adopted and changed, so that it's maybe different to, let's say, well-established technologies. And especially when looking at recovery rates, they are more likely to increase. And also when you have seen the circular footprint formula when it comes to the composition of materials. So when you look what's in the battery to produce a cathode active material, you either use, for example, lithium hydroxide or lithium carbonate, but what could come out of a recycling would be lithium sulfate for many recycling processes. Yeah, could be also lithium hydroxide, but there are different kind of chemistries going out. And then it's also a question how to deal with these outcomes. Is lithium sulfate then equivalent to lithium carbonate going in, or is it something different? Yeah, so there also more definition needs to be done, right? And you were also asking not only from recycling, but also for cathode active production. There I see challenges in the value chain that could also change quickly. Yeah, so for example, looking at PCAM, if a CAM producer is supplied by a PCAM producer, yeah, and that PCAM consists of nickel that could come from 10 different refineries where there are 5 different mines behind. Yeah, and if PCAM producer changes the supply chain, of course, that would have an immediate effect on the PCF. But how often will the PCF be updated? Is 1 year sufficient, or does it make sense, right? So these are all things where I think the usage of primary data for recycling and for PCAM and the upstream value chain, that is something that we would like to go for. But these are the big challenges, and therefore I think it also makes a lot of sense that from a starting point in the law that it's said, yeah, these data can be also secondary, yeah, because sometimes you cannot collect all of it. Yeah, if you're able to do so, you can then do it voluntarily to show your carbon footprint and have a better quality of the calculation. But it might be that not everyone would be able to do so. Yeah, and that is also something where I'm also not sure when materials buy it in the spot market or the trade from traders, right? If they also are aware or can they calculate the PCF of the material they deliver to a PCAM producer, for example. So I see a lot of challenges when fulfilling the voluntary part of the batteries regulation regarding the CO2 footprint.
Thank you for that. Yeah, I'm hearing that you're optimistic, but obviously you also see a lot of challenges in the concrete implementation, especially regarding data confidentiality you mentioned, also data storage, and obviously the fast technological developments should be taken into account. I want to go a little further into one topic that you mentioned a little bit, the primary versus the secondary data. So there I would have 2 questions. The first one for Kita and the second one again for Bodo. And the questions are around the topic why the battery carbon footprint is actually important to decarbonize the battery value chain, and what the role of primary versus secondary data play in this. So Kita, how can the battery regulations carbon footprint requirements enable decarbonization in the battery value chains from the battery manufacturer's perspective?
Mm-hmm. Thank you for the question. So to start off with, we talk about how the data flows between the different different users of the carbon footprint calculation done specific to a material, for example. Once the carbon footprint calculation is done, a key thing is to really understand what does it mean. And with the regulation which is certainly a step in the right direction, but now we come to the details, and I think they are very important here. So one point is how the data is actually transferring, and I believe Bodo mentioned those challenges around that. When we are talking about where the data comes from, is it secondary or primary? I would really start off with explaining a little bit on secondary and the primary data. So primary data is the company-specific data, which is collected and calculated as an activity data on the company level, using secondary data in the background. And this data set then refers to as, or could refer to as a primary data. That is one way to look at it. And then this data set will go to the next company, where that will be considered as primary data because it has been collected using the upstream activity data specific to the company where the production of that material is happening. Then we come to the secondary data, where when we don't really know exactly where the materials are coming from, and if we don't have access to that data, we need some data to fall back on, which oftentimes is collected using an average, a representative average of the market, or sometimes from research and so on many other ways how this data has been gathered on a general level, and then it can be regionalized on Europe level or going wider or going narrower. I think here, regarding the secondary data, one thing is really clear is that in terms of data quality, primary data is much better representation and accurate representation of the impacts compared to the secondary data. There are some challenges with calculating that, but it allows the user to really understand where the hotspots are located. So it allows companies within the battery value chain to find out what are the key actions that they can take in order to decarbonize their own processes. And as a result, bring benefit to the downstream users as well. I mean, the idea behind the declaration of battery carbon footprint, I believe, is to really have informed opinion of the consumer to know which batteries are more sustainable than the other, and so on. So if done right, using proper primary data, it can serve its purpose. Of course, there are some challenges and some things to still iron out, and those details. But essentially, understanding where the hotspots are located in the upstream, identifying what to do with them and how to improve forward and bring the user or the consumer best and the lowest carbon footprint is something that is possible because of having this development done. And I think that is certainly a really good outcome of this.
Yes, thank you. So I understand that the primary data basically supports the identification of the actual hotspots in the value chain, and then obviously you can build the basis for actions on how to decarbonize those hotspots. So thank you so much for the explanation on this. And now I want to ask Bodo, what do material suppliers actually think about the carbon footprint requirements? Do you think that also how Ketan kind of explained it, that they can enable the decarbonization of your value chain?
Yes, exactly. So I'm 100% with Ketan concerning the argumentation to use primary data. And that is also one of the reasons why BASF on a corporate level runs a so-called CO2 supplier management program, where we proactively ask all our suppliers, so that's for BASF 45,000 suppliers, that we ask them about the carbon footprint and also want to know about the about the update, and we also challenge the data that we get using secondary data to do some validation and plausibility check. And of course, why do we do that? We have seen that the data we buy in has a huge effect on the carbon footprint of the products we produce, and especially that is the case for looking at cathode active materials. So for starting with cathode active materials before talking 2 sentences about recycling, for cathode active materials, we have seen that most contributor comes from lithium and from nickel. For nickel, maybe you have seen from some consultants these CO2 curves, that show a factor of 10, depending on where you source the nickel from. And that has quite a huge impact on the PCF of the cathode active material. That means if someone uses an average value, then of course that cannot be representative for a huge spread of factor 10. And then of course you need to understand, where's the material coming from? Does it come from Northern Hemisphere? Then the PCF is likely to be rather low. Or does it come from tropical regions? Looking at tropical regions, there are 2 processes like the H-Pol process or the RKF process. RKF process means the rotary kiln electric furnace. And if you know that a lot of electricity is being consumed in countries, electricity produced from hard coal in countries like Indonesia, then you can imagine how high the CO2 footprint is. And then you also see that using an average data set for nickel sulfate is not appropriate, because the actual carbon footprint using this kind of material would be way higher than the one using the average. So that is, at least for the cathode active material, we strongly go that way to get primary data as much as possible, and to really also challenge our suppliers in this regard. Where's the material coming from? Is there anything they could do to optimize? Maybe if it comes from Indonesia, if there is also plans to get other electricity mix, maybe electricity not produced with hard coal, but maybe with photovoltaics or biodiesel or things like that. So that is something where you at least you can steer, and without having these numbers and primary data, you couldn't have these talks to optimize the value chain. And that is basically also the reason why we say we should also use primary data for recycling. Because if we want to optimize our process, we need to see where are the hotspots for recycling. And therefore, of course, if we would just use secondary data, we can't see any hotspot. Therefore, we would also need primary data on that if the goal is to optimize the process. If it comes to report a PCF of an electric vehicle, and using, as Achim mentioned, a method that assumes recycling that happens in 15 years from now, no one knows about technology there, then this is another purpose. So therefore, I think if you fulfill the mandatory requirements of batteries regulation using the CFF, that is another purpose. It cannot be used to optimize your process. Therefore, you need to use the cutoff approach, as Achim pointed out very well.
Thank you.
Anna, can I add on to the point what Bodo mentioned around secondary data set? I think it's really important to have granular and accurate secondary data. Otherwise, the way, and now we are going to go more into the details of how the formula and how the accounting is actually structured at this point. So if we have a secondary data, which is, let's say, lower than primary data, and when we have optional primary data, then there is a high risk that the secondary data is lower, because either it can be 2 reasons, because either it is an average lower, or on the other side, it is, let's say, not an accurate representation of the process. It might be different in scope, or it might be just a partial representation of the whole market. So with this, we really need more granular secondary data sets, which will allow the accurate calculation of the carbon footprint. And then those data sets should be made to be used while calculating the carbon footprint. Otherwise, there certainly is a high risk, because as you go more into the details and as you calculate more, expand the scope more, you end up with a higher footprint, and then it could be considered that, okay, am I really not doing the right counting, or is that something to be improved in the secondary data? So I cannot highlight more to say. There are a few initiatives out there as well. HiQLCA is one of them. It's a project funded by EIT Raw Materials, where the idea is to develop more granular secondary data sets for battery materials. And I think that is allowing those data sets to be included as this goes forward, because there will be more and more processes and methods developed to produce these materials. And they should be made, and the regulation and the rules should be made in a way that allows those positive improvements towards environment and improving the processes, for example.
Yeah, thank you so much both for explaining the importance of primary data for optimizing processes, but also on the other hand, highlighting the importance of granular and accurate secondary data sets, Ketan. Next, I think Bodo has mentioned it already a little bit. I want to ask about the end-of-life allocation. So you're both working in companies that are also battery recyclers. What are, in your opinion, the practical implications for battery recyclers of the proposed EU circular footprint formula that has been explained by Achim already a little bit earlier? Does the circular footprint formula help you in terms of incentivizing battery recycling? Maybe Bodo, you can start, and then Ketan can add again.
Yes, thanks, Anna. Yeah, so as you have already heard from me, it's a lot of rather smaller players are also in the recycling business. Yeah, so therefore, this rather complex formula and the parameters that needs to be collected might not be very easy for them to do, right? And therefore, I think at the end it will be very probable that a lot of companies use secondary data because not all of the parameters can be collected, the primary ones. And then, of course, I see no differentiation potential when everyone uses the same secondary data for the recycling, just for practical reasons. And as I said, to my point of view, the incentivization really comes to optimize the process, and therefore the CFF doesn't help, because there's so many parameters in, and as Achim said, CFF leads to a lower CO2 footprint, because you assume something happening in 15 years from now, and I want to optimize the process as it is at the moment, and not knowing what will be in 15 years from now. So therefore, it's just a different purpose, and there I don't see any incentive for using the CFF in this regard. And additionally, I see a big challenge. As you see, it's now a European regulation, and outside of Europe, most probably companies will follow the GBA rules, where a cutoff approach is proposed. That means if you do a PCF of an electric vehicle in the US, for example, or in Asia, will be completely different to the one in Europe, right? Even though it might be same recycling technology, but outside Europe, no one will use the CFF. So therefore, I really wonder how that helps us. And additionally, looking at BSF, as we of course do not only produce cathode active materials, but a lot of other components going in a vehicle, like plastics or lubricants, tires, so coatings. That means all of the PCF for the other parts of the vehicle, even in Europe, will be calculated using the cutoff, and only for batteries we will use the circular footprint formula. So that means for the vehicle, you have then at the end a mix of different methods that are applied. And there I also wonder how that helps, because also the OEMs that are then our customers, they would get PCFs calculated with different methods for different materials they purchase from BSF. So therefore, I see there some problems from the logic. If all the standards, the international standards like WBCSD, like TFS, like GBA, all follow cutoff approach. And for batteries, only in Europe we do something different that doesn't fit to the rest of the world and the rest of the vehicle, right? So that is basically some problem where I don't see any incentive. I see just additional work. Yeah, you need to do a reporting, calculate the PCF of the cathode, including recycled material with the cutoff for outside of Europe, and with the CFF for inside of Europe. Yeah, so that's just additional effort and brings no value add from my perspective.
To continue this a bit forward, I might take a slightly different opinion and shed a little bit of light on cutoff approach. And when we talk about CFF, we oftentimes refer to CFF, but the clarification around this is CFF in a way that the assumptions and the A factors and the recovery rate that is in the current draft. Because CFF is a formula which can be leaning towards cutoff or leaning towards substitution, depending on the parameters that you use. So I would go back and say this again, that it's not the formula which is something different. It is essentially the same formula with more parameters in them. And then how it's really important how those parameters are considered as a baseline. So we talk about A factor or the credits coming from recycling of the materials. And then the logic is same. When you have a default number, which is lower in the production side or higher in the credit side, which in the end allows you to get a lower number, what happens as a result is basically you have a risk that you rely on the secondary data just because it is something that allows you to get a lower number. And I think the parameters understanding really for specific to battery materials, what are those? And in the battery materials is the recycling capacity, which needs to be incentivized, or including the recycling that is or recycled materials that needs to be incentivized. It can be going in any direction, either in the direction of CFF or in the direction of end of life. Now coming to cutoff. I meant now coming to the cutoff approach. When we are modeling a product footprint using cutoff approach, it is really important to still do the end of life modeling using some as you said, either gate to gate model or something that will allow you to quantify that and improve that further. Because in itself, in the cutoff approach, you only consider a part of end of life modeling and the product, which there is no requirement on that product to be recycled at the end of its life. Because to design the products which are to be recycled at the end, it is important that that point is also, or that scope, that the process also falls under the scope. So I would say it depends really on how parameters are structured for CFF, and then it can lean in one direction or the other, and that needs to be improved. Yes, I agree.
Okay, thank you so much. So I hear from Bodo's side the mentioning of CFF being additional work, and also the need for harmonizing it with international standards for sure. And then Ketan, also thank you for clarifying again that within the circular footprint formulas, obviously the parameters are very important and how they're set, and also how the methodology behind it is defined in a way, as you mentioned, that actually, for example, the design for recycling is taken into account. And I think this is something that needs to be then included in the methodology as well. So I would now actually dive into the Q&A session and invite Achim back on the stand. And I will look at the questions which are posted in the Q&A function, and would start with the ones that just have the most upvotes. So which I then find that probably most people are interested in. So the first question, and maybe Achim, you can start with this, because you have been spending a lot of time in this process. So there are differences between the CFB, which is the carbon footprint for batteries, for those people who don't know the abbreviations, and the PEFCR, which is the product environmental footprint category rules for batteries. In the battery regulation, only the PEFCR is named, or PEFCR. How can we be sure that the carbon footprint for batteries document will be used?
Thank you very much for that question. And yes, we spent, all the three of us, a lot of time in these working group meetings. And I think it is very important to understand that the CFB document, so the JRC rules for the carbon footprint for electric vehicle batteries, are basically the proposal of the Joint Research Center and the European Commission for the delegated act that will be implemented over the course of the next 6 months. So the document per se will not be used. It will be only used if it is translated into law. And the regulation actually says that this methodology specified in the delegated act needs to be in compliance with the PEF and PEFCR. So there needs to be some harmonization, and there are still certain gaps, but coming from the discussions, there will be, of course, harmonization and alignment, because you cannot have two competing set of rules, so to say. But if it gets really down into the details, it is obviously very tricky to find consensus on each of the parameters of the circular footprint formula, for example. But still, the JRC CFB document is only valid if it is translated into the delegated act, but it has been proposed as the basis for this secondary legislation, and thereby we expect that most of the document at least will be translated into law, pending, of course, approval of the European Council member states.
Thank you so much. Does anyone want to add on that? No. Okay, then let's move on to the next question. Why is an own footprint formula developed and not done via life cycle assessment of, for example, CIMA Pro or another life cycle assessment program or software? Maybe Ketan, this is a good question for you.
Ooh, very, very much leaning on speculations, but I might take a venture a guess on why this might have been, and I hope our expert panel to chime in where necessary. So the idea, I believe, would have been more accurate representation, and for example, CIMA Pro or another LCA program is something that is used by a set of parties, let's say, and not all of the members who are supposed to report. So prioritizing one over the other might have been in the direction of selective preference, which shouldn't be the case, and to make it more general, that might have been the idea.
There are no more additions.
I mean, maybe quickly adding here, if with the footprint formula, the circular footprint formula is meant, I am highly certain that this will be implemented also in any LCA tool, if it is obviously implemented in the delegated act, which is kind of to be expected. But yeah, I think that technology providers will actually catch up.
And then if it is more on the circular footprint formula, for example, then I believe the idea might have also been to not restrict itself to battery sector and make it more general, and that could be the understanding.
That is actually a very good point, because in the European Union, there will be many more carbon footprints to be declared over the course of the next decade, I think, because the Eco-Design for Sustainable Product Regulation also has kind of these implications for other product categories beyond batteries, and therefore this circular footprint formula and PEF methodology is rather general, but it is implemented to product-specific applications in the PEFCRs, and then obviously when regulation for other products come in, then also in JRC rules and delegated acts.
And as far as I understand, also the CFF is also implemented to a certain extent in the environmental footprint compliant data sets. So,
indeed, certain parameters are specified for the secondary data in the EF compliant databases.
A next question for primary data from battery assembly plant, so at the OEMs, what is the guidance on primary energy consumption data for new manufacturing plants which are either not ramped up to full production capacity or not yet commissioned? Does any one of you know a specific answer to this?
Maybe speculating because I don't understand fully the question, but when it goes to primary energy consumption data, maybe that leads to the discussion if electricity is used, is it electricity coming from national grid mix, or is it electricity covered by, let's say, power purchase agreement, so that someone produces green electricity and that kind of electricity is being purchased. And according to the JRC document, this is one measure to lower the CO2 footprint. Yeah, if you buy green electricity, so you don't have to produce by your own, so you're also allowed to buy green electricity. You need to have guarantees of origin, so some certificates that prove that you purchase green electricity, and that green electricity would replace the national grid mix.
If I may add quickly, because, or Ketan, you unmuted, maybe you have something to add.
No, please go ahead.
Because I think, and this is also speculating because I don't have all the methodologies line by line in my head, but I think the GBA rulebook, for example, has an exception for newly erected or in ramp up phase plants, such that the electricity modeling has a certain cool or ramp up period under which other conditions apply, because I think it's not easy to fulfill the physically modeled approach if you erect a new plant. But I think this would require certain rereading on my part, but maybe this triggers something in your brains because you also work with this document. But if not, I think Bodo highlighted very well that you have either on-site generated electricity, supplier specific electricity, residual consumption mix or average consumption mix, and then there are conditions under which you should actually follow these model steps in the JRC, because we all know that electricity carbon intensity is the biggest impact factor along the value chain. So it has strict conditions under which this is applied.
Yeah, and to add on to that, I think the way rules are structured for electricity modeling is for now I'm talking specifically on supplier procured electricity product, and that is more on the system, which allows uniqueness and traceability of different energy or electricity attribute certificates. So in Europe, we have an example of guarantees of origin system, and outside Europe, I think that there are different systems. In order for those systems to be compliant, there are specific requirements. So it really depends on the question doesn't specify which part of the location or the globe are we talking about, but how the draft report is structured is in the following, where there is criteria for what is allowed, and you have to start to see really if the system which allows uniqueness and attribute tracking of the electricity product is complying with the requirements. If it complies, then you're allowed to buy this. And then the question can be to dive a little bit more into the detail of this. It can be taken into direction: are the current criteria granular enough? Because GBA rulebook allows two different ways to report it, and I believe it's a wider discussion being taken into many different directives and upcoming regulations, and also different spheres, how to track and what really accounts for accurate measurements of electricity modeling. Should it be 24/7? Should there be an additionality aspect involved? And if there is something else that need to be addressed. However, currently how it looks is within a specific market boundary, if the system in place is compliant to the requirement, you can use the guarantee of origin.
Thank you so much for that answer, all three of you. next question would be, how would the verification and auditing of this carbon footprint data work? Maybe Bodo, you can start, and then Kita can add from a practical point of view.
Yeah, so basically, my personal view on that would be that it should be according to the ISO standards, right? So if a carbon footprint is calculated, then you would need an independent review on the calculation. For sure, if the chemistries are similar, maybe then you can also put the work together to a review panel, but that is basically how it works, right? So if you disclose a PCF, yeah, and the value chain should trust the PCF, you need some kind of independent check on the data calculation. So in battery pass, we haven't talked about that, but there I would really stick to the ISO standards, what's being required there.
And to add on to that, I believe the idea for Europe was to empower for member states to have a designated body who would conclude these verifications and who would carry out the verifying function. And then there are a few requirements on what does actually verification mean, which is I believe structured in a way to separate two things, which is keeping the confidentiality aspects intact and protecting the PCF calculations to be accurate. However, after having a level of assurance, they can be taken as a number.
Thank you so much. And I think even in the battery pass consortium, we are still working on specifying the auditing, not specifically now for the carbon footprint, but in general for the battery pass data attributes. So this is something where we will then also publish some work on. So a next question would be, how do you define the battery system? Which components do you consider to be affected? For example, the thermal management. Achim, as you have talked a little bit about the system boundary, maybe you want to take this one.
I can start, but I mean, even though the JRC proposed a certain system boundary, I think this will be a very interesting topic because obviously each battery is different and therefore different components are included. But in general, all of the, so to say, active components, so cathode, anode, electrolytes, etc., need to be included, as well as the major passive parts, such as the battery management system and the thermal management unit. I know that previously it has been discussed whether the inverter should also be included in the system boundary, but since it's not explicitly stated anymore, I think it has been, it's now outside of the system boundary. But for me, it also is still an open question on which will probably also be defined if we speak about other battery applications like industrial batteries. But what if there are, for example, new inventions where you have a new component adding a certain share of carbon emissions? But I think there will be in some form or the other a process of identifying the hotspots of potential other components such that they need to be included. And I think the big task the JRC had is to stay as vague as possible, to also include other components that might come up, but to be as prescriptive as possible such that the same system boundary is applied, because just leaving out one component obviously adds a different carbon footprint.
Thank you so much for that answer. The next question is directed to Bodo. 45K suppliers required to real data. So what, oh, I've lost it, I'm sorry. Yeah. What role do platforms play? They are great on managing access, transparency, and governance, and they scale also down to spot market or players. So I think the question is basically, what role do platforms play?
So I can say, when we as BASF approach our suppliers, we create our own platform. So the supplier is addressed by our purchase colleagues. They are informed, they get a link to this platform. There is a list of questions. They answer the questions and submit the PCF on this platform that we developed. So therefore, there is no third party that has some insights in what kind of information will be shared from the suppliers, because this is confidential information. And there see the big threat if some consultant collects all the data, let's say from our 45,000 suppliers, yeah, and would start to compare those, or even if they don't do, someone hacks this platform and then the data is leaked. So therefore, we have that then under our control, and there is no third party using this platform. So therefore, we are a little bit careful in this regard, as we know there is a lot of platform providers out there. Yeah, maybe we need further align there and see what kind of security systems third-party providers do have. But that's basically a big topic, and I know that also in Catena X, that's an initiative founded by, especially in Germany, a lot of OEMs and the automotive supply chain contributes there. They were exactly addressing this topic. So how should a platform look like to guarantee that data is handled secure and that not data can be leaked? Yeah. So, but there I'm not the expert. I just repeat what I know from that. But I think Catena X is very much advanced in this regard, as far as I understand. So when it comes to exchange with, on the whole value chain, or not, let's say, the suppliers to BASF, yeah, because that's our own solution. But I know we would need it for the whole value chain, and maybe the alignment with Catena X would help.
Thank you so much. Does anyone want to add? Otherwise, I would jump to the next question. Okay. So the next question is that it seems for non-mandatory data, the use of secondary data sets is mandatory. If primary data is available, why would this not be used instead? Maybe Ketan, you want to start?
Yeah, I think this. I don't think I'll be able to answer why it's not to be used. But what I can say is the idea behind. I would put it this way: the idea behind having a few of the data sets mandatory is that the hotspots or the parts which are identified as the hotspots, for those parts you need more accurate data, and then primary data needs to be collected from those database or those parts. Sorry. So if there are a few parts that are outside the scope and are coming up as relevant processes, then they certainly should be in the scope. And then I am not certain about the battery management system. Was it? Or okay, it was a general question. Then I take it in a slightly a bit of a different direction. So where, for example, synthetic graphite or specific materials which are in current state, or how the overall production market is structured right now, might be a few of the hotspots. And then if they are outside the scope, then the question still remains: are we really, with the mandatory data for the defined scope, are we really improving the quality of the product carbon footprint for the right process? Because if the hotspots are outside, then there is still a big risk that those are never included in the mandatory data collection. And we are just not looking at the right part of the problem and leaving it out of our sight. And in that regard, I would certainly say that in these cases, they should be included as a mandatory data to be considered in the product carbon footprint. And outside the scope, the idea behind having a secondary data might just be that there are a few materials where the production processes are quite complex, but in these cases, the secondary data quality certainly should be improved and made more granular, and a few of the previous points.
Yeah, and maybe to add to that, having again the perspective looking upstream. So I already explained how big the spread is when it comes to potential PCFs for nickel sulfate, and therefore, of course, it's not forbidden to use primary data, and that is really our goal when it comes to material from mining and refining. Of course, if there would be a mandatory need to disclose that, then we would have a bigger lever. Yeah, because as I said, we have this CO2 supplier management program. We apply at BASF, but the supplier could still say we don't deliver the data, and then we need to think about what would be the consequence, right? Could we work with other suppliers if they are not eager to deliver? Maybe they have something to hide. Yeah, you're not know. Yeah, you're speculating then. And if it would be a mandatory requirement for upstream up to the mine, then that would of course help us very much to have a very accurate carbon footprint of our cathode active material. So therefore, from our view, it's a pity that it's not mandatory upstream. But yeah, you can do, yeah, and I fully agree with Ketan that average data is not helpful, so you should have better secondary data, for example, for different process routes. Yeah, that you say you have, for example, for HPAL, a data set for HPAL nickel or RKF nickel or nickel from, let's say, from sulfidic ores from northern hemisphere. So that would be would bring much more transparency into it, and not using just one data set for nickel sulfate that tells you basically nothing. Yeah, it's something in between, but you don't know the worst case then. Yeah, and that is maybe the biggest threat there, that no mandatory data is used and no appropriate secondary data is available, at least from my point of view. Looking at recycling, as I said, I see it quite different as recycling processes very much changing a lot, and we don't know how the situation will be in 15 years from now. Yeah, so once the circular footprint formula needs to be applied, there, I think primary data cannot be collected because there is no time machine to look what happens in 15 years from now. So, and therefore, I think secondary data makes sense for recycling using the circular footprint formula, but to optimize the own recycling process. So we as BASF, we want to optimize our process. For sure, we then also use primary data also from suppliers that might deliver black mass or battery scrap. Of course, therefore, we need primary data because that is just another purpose than what's intended by the battery path.
Yeah, fully understandable. And thank you so much for these insightful answers. Sadly, we have to wrap up the Q&A session, and now we are gonna try and answer as much as we can still in the chat, as we've already started. And also I want to indicate that we are collecting these questions that are posed in the Q&A function and developing a frequently asked questions section on the Battery Pass website. So so you're ensured the questions are not lost. We will have a look at them. And yes, thank you so much again to our experts, Bodo and Ketan, for joining us and providing all these insights. And I will hand over back to Tilman now.
Yeah, thank you, Anna. And I can just follow your point. Thank you very much, Bodo and Ketan, for this very, very insightful voices from practice, from actual business, implementing these measures. It really shows like the very, very serious consideration of carbon footprinting in your daily work and the deep expertise that you bring. Not easy topics that we're talking about, quite complex, even to start discussing, let alone finding conclusions. So thanks a lot for sharing this info with us. Now, just a few more minutes before we wrap up, hopefully on the hour. I'll just give an overview where we stand, what's our next steps, and then closing up. So as we said in the beginning, today marks the end of our webinar series. You'll find all of the recordings on our website, the link being here on the bottom. So just navigate to thebatterypass.eu. Go to the events tab and you'll see the series and the recording. So we'll obviously also upload today's recording there as soon as possible. Next slide then for the next steps of our project. So As we said in the beginning, today was all about the content standards, and in the future, of course, we're focusing also, or in the current live focus work stream, on the technical standards, meaning what could be the reference framework for all sorts of battery passport providers and contributors to the upstream data input. We learned today these will be quite necessary, right? It's about aggregating data along a very complex supply chain. So how can that be done and made interoperable and secure? So that's our core work stream right now. However, content standards isn't quite finished yet. So for one, we'll update the content guidance now with just launched European battery regulation to make sure that it's all conclusive and final. We're also shifting a few things that were more of a positioning and recommendations to the European Commission into Commission paper that we're just wrapping up, and we'll bring out as a comment towards the incoming delegated acts process. And we'll also look into how to bring that expertise that we've built over the last year into those processes to make the most sense out of the incoming legislative process. And of course, we're engaging really deeply. One great question in the Q&A box was, how do we interface with the other initiatives that are around there, like the Global Battery Alliance, Catena-X, Surpass, and Circuit, BAT, and so on? And we are actively engaging with them, and we'll keep doing so for the next years. Yeah, technical standards, please keep your eyes peeled. We're going to have a consultation phase end of the year towards Q4. So keep your eyes peeled if you're into that field. Please, we're really looking forward to your comments. Do reach out. And then obviously building the demonstrator based on the draft technical standards, so we can actually prove that this is working. Yeah. And then lastly, if we can move to the final slide, please, if you have another 2 minutes until the full hour, please whip out your phone. We are really looking forward to your feedback, helping us to improve further. Just a quick 2-minute survey while you still have the time. Just take out your phone right now and go through this little survey that the team set up. And with that, we'll leave you today. Thank you very much for your participation, the great and thorough questions, your time and attention. Thank you, Anna, Achim, Steffi, Bodo, and Ketan. It was a great webinar. And with that, have a great day and see you all soon. Bye.
Thank you. Bye-bye.